Okay, so we're gonna start now. So the name of the course is Introduction to Algebra for Math Competitions, and I'm your instructor, Shreyas Shrivastava. So if you have any questions, you can either message me in the message box or you can email me at the said email. Please keep your mics muted. And after each topic, I'll present some questions to test your understanding, and then we'll discuss the solutions. For those who find the questions too easy, there will be some challenge questions at the end. Most importantly, have fun. I'll try my best to make the class fun and understandable, but I'm not perfect. So if you see any mistakes, feel free to point them out. Also, feel free to review the session at Alphademic's YouTube channel and also subscribe to them. Okay, so this week, these are the 5 topics we're going to go over. First, we're going to do some pre-algebra review. Then we're going to do some introducing variables into pre-algebra. Then we're going to go into linear equations. And then we're going to go into linear equations with multiple variables. And lastly, we'll have some challenge questions. And this week's lessons were prepared with the help of the Introduction to Algebra book from AOPS. Okay, so for pre-algebra review, first I want to go over order of operations. When you want to remember BODMAS and PEMDAS, which basically means first you evaluate everything inside the parentheses, then you perform all exponentiations, and then third, you perform all multiplication and division from left to right, and fourth, you perform all additions and subtractions from left to right. Some important things to keep in mind is addition and multiplication are commutative, meaning a plus b is equal to b plus a, and ab is equal to ba. And they're also associative. So a plus b plus c in parentheses is equal to a plus c in parentheses plus b, and a times bc is equal to c times ab. And the distributive property is pretty useful as well. It saves a lot of time, especially in math competitions. It basically says a times b plus c in parentheses is equal to ab plus ac. And also something I've seen a lot of people do is when you have a fraction and you see common factors, you can cancel them out. But if you're adding them, if you see 2 plus 9 over 7 plus 9, you can't cancel the 9s out. But if you do 2 times 9 over 7 times 9, you can cancel the 9s out. Exponents are basically an easier way of writing the product of the same term over and over. So 2 times 2 times 2 times 2, it can be said as 2 to the power 4, and it can also be written as 2 to the power 4 like that. And then exponent multiplication is essentially the same as addition. All you have to do is add the powers. So 2 to the 4 times 2 to the 5 is equal to 2 to the 9, not 2 to the 20. So you have to do 4 plus 5, not 4 times 5. And addition and subtraction don't work like that. There really is no trick to do them other than factoring for addition. So you have to do 2 to the 4 plus 2 to the 5 is equal to 2 to the 4 times 1 plus 2 to the 1. And for division of exponents is just subtraction of powers. So 2 to the 4 divided by 2 to the 5 is 2 to the 4 minus 5, or 2 to the negative 1. And if you see a negative exponent, don't be scared. It simply just means 1 over the positive power. So 2 to the negative 1 is 1 over 2 to the 1. And radicals are basically exponents, but with fractional powers. So 25 to the power half, it can also be written as square root of 25. And this means what number multiplied by itself is 25. So the number would be 5, because 5 times 5 is 25. Something important is when you see the square root, the root that you're finding is always positive. So for the above question, we can't say negative 5. We have to say 5. And in general, a to the power 1 over n is said to be the nth root of a, and can be written as like this, nth root of a. Another thing to note, for any nth root for n even, there could be 2 possible numbers that work. While for odd n, there's only 1 number that would work. But as we said before, you always take the positive if it's even. And when asked to simplify a radical, you want to look for a factor that can be taken out of the radical. So the square root of 125, that's also the square root of 5 to the power 3. So you can take out a 5. So it becomes 5 times the square root of 5. Okay, here's some review questions. I'll give you guys a minute to work on them. Okay, I'm gonna go over them now. So for number 1, it's just 7 to the power 4 over 7 to the power 10. So that's essentially the same thing as subtraction of the power. So it just becomes 7 to the power 4 minus 10, or 7 to the power negative 6. So x is negative 6. For number 2, you want to like radicalize them. So square root of 28, you can write that as square root of 2 squared times 7. So you can take out the 2, so it becomes 2 root 7. And then the second one, you can write that as 3 root 7. So minus 3 root 7. Sorry, not 3 root 7. Yeah, 3 root 7, sorry. And so it becomes negative root 7. And then as for this one, 175 can be factored as 5 times 35. So 5 squared times 7. So that can be written as 5 root 7. So it becomes 2 root 7 minus plus 3 root 7. And then minus 5 root 7. So it essentially just becomes 0. Okay, and then the third one, you can use the distributive property. So it just becomes 6 times 2, which is 12, plus 6 times 6 squared, which just becomes 6 to the power 3, or 216. So this is just 228. Okay, for this one, so we're doing multiplication. So what you do is you write, this is 2 to the 3, the square root of 2 to the 3. So that just becomes 2 to the power 3 by 2 times 4 is 2 squared, so 2 to the power 2 by 4. And we said I mentioned how multiplication is essentially addition of the powers. So this becomes 3 halves plus 1 over 2, or 3 halves plus 1 over 2 is 2. So it just becomes 2 to the 2. So x is 2. Okay. Okay, now we're going to bring in variables. So variable is basically a placeholder. So when you combine numbers slash variables, you get an expression. The operations we discussed previously can also be performed using variables. Some stuff I find important is like x plus y whole squared is equal to x squared plus y squared plus 2xy. And factorization works the same way for variables. So 5x squared plus 6x cubed, you can factor out the x squared. So it just becomes x squared times 5 plus 6x. For fractions, you add and subtract them the same way you would with variables. Okay, here's some questions. I'll give you guys 2 minutes to work on them. Okay, I'm gonna discuss them now. So this is basically saying what is 36 y to the 8th divided by 3 y to the 5th, and that's just 12 y to the 5th, 12 y to the 3rd, and then the second one. So you can like multiply it out, and you get like the cube root of 243 times the cube root of y to the 12th. And so let's look at this part first. The cube root of 243, that's essentially the cube root of 3 to the 5th. And that's just 3 to the 5/3. And you can like take out a 3, so it becomes 3 times the cube root of 9 times, and the cube root of y to the 12th, you just think, what do you multiply by itself 3 times to get y to the 12th? And that's y to the 4th. So it's just y to the 4th. As for the third one, you can use the distributive property. So it becomes 16 times x over 2, which is just 8x. And then minus 16 times 3/4, which is just 12. So it's 8x minus 12. Okay, so for factoring, you have to take out basically the factor from both the terms. So in this case, the GCF of both these terms is x squared minus 3. So you can take out an x squared minus 3 from both of them. And then times 2x plus 5. It's basically the same thing as distributive property, but you're working backwards. Okay, for this one, you want to take out a fact. Oh, this is supposed to say 15x to the power 5, not z. So basically, you have to take out a factor from both of these. So you find like what's the greatest common factor of these three terms first. Of these three terms, you can take out a 15x to the 3. That's basically the greatest common factor of the top. 15x to the 3 times x squared plus x plus 1. And you're dividing that by this. And the greatest common factor of this, the bottom part, is 12x. You could take out a 12x. And when you take out a 12x, this becomes x squared plus x plus 1. Okay, so now you know you can cancel these two factors out. And then as for this, you can cancel an x from both of these, so it becomes x squared here. And you can cancel a 3 from both of these, so it becomes 5 here and 4 here. So basically, it just becomes 5x squared over 4. So that's our answer. Okay, this is the last one. So for this one's kind of hard to figure out, but basically what you notice is 8r minus 56 is just 8 times r minus 7. And you also see here that this is 2r times r minus 7. So we can take out an r minus 7 from both of them. So this becomes r minus 7 times 2r plus 8. And if you really wanted to factor in more, you could have taken another 2 out. So it just becomes 2 times r minus 7 times r plus 4. Okay, so now let's move on to linear equations. Solving a linear equation basically means solving for the values of the variables for which the equation is true. So when you're asked 4x is equal to 20, solve the equation, you want to find the value of x such that 4x is equal to 20, and which would be when x is equal to 5, because 4 times 5 is equal to 20. The same strategy of solving these equations applies to the previous topics we were talking about. When you tackle these problems, you want to manipulate the equations so that they're easier to solve. So you also want to isolate the variables. So basically, if you're given an equation and you have like a bunch of numbers on one side, you want to make sure that the variable is the only thing on that one side. So you subtract numbers to get it in such a way. And there's also sometimes there's like linear equations which look like they're complicated, but they're actually really easy. Like this question right here. So like this question right here, it says the cube root of 2x plus 1 minus 5 plus 2 times the cube root of 2z plus 1. Okay, that's supposed to say 2z plus 1, not 2x plus 1. Is equal to negative 14. Okay, so it seems kind of complicated, but if you set the cube root of 2z plus 1 equal to x, then it basically just becomes x minus 5 plus 2x is equal to negative 14. So x minus 5 plus 2x is equal to negative 14. This is just a linear equation, so it's just going to be 3x is equal to negative 9. So x is negative 3. And we set the cube root of 2z plus 1 equal to x. So the cube root of 2z plus 1 is equal to negative 3. So you can cube both sides, and you're going to get 2z plus 1 is equal to negative 3 to the power 3, which is just negative 27. Or you'll get 2z is equal to negative 28, so z is equal to negative 14. So it looks pretty hard, but it's actually really easy. Okay, so here's some questions. I'll give you guys 2 minutes to work on them. Okay, let's discuss them. So for the first one, this is distributive property. So you can distribute the 2 to all the 4 terms. So it just becomes, so it's going to become 2 times a, so 2a, 2 times b, so plus 2 times b, which is 2b, and then minus 2 times 3c, so that's just minus 6c, and then minus 5 times 2, so minus 10. So that's our answer for the first one. Okay, so for the second one, this is just like adding fractions, but they're just variables. So you look for the LCM of the 3 denominators. So what's like the number that you can get from each of the 3 numbers? That's like the LCM of the 3 numbers. In this case, it's going to be ABC. So the denominator is ABC. And then the numerator, what you do is you divide ABC by A. So that's BC. And then this will be ABC divided by B, so plus AC. And then plus ABC by C, so plus AB. So that's our fraction. Okay, so for the third one, you know how like variables are placeholders. So in this case, the A is the placeholder for negative 5b. So we can put negative 5b into this. So it would become 2 times negative 5b, so negative 10b, plus 3b b, and then this is just going to become plus 5b, and then plus 2b, and then plus 5. So this just becomes negative 10b plus 3b, which is negative 7b, plus 5b plus 2b, which just becomes 0. They just all cancel out, plus 5. So our answer is 5. Okay, so for this one, you want to like distribute the x to each of these two terms and the 1 to each of these terms. That's going to, it's going to become x squared, because x times x, and then minus x times 1, so which is minus x, and then plus 1 times x, so which is just x, and then minus 1 times 1, so minus 1. So it's just x squared minus 1. So we noticed that x plus 1 times x minus 1 was just this term squared minus this term squared. So we can kind of generalize that x squared minus y squared is just going to be x plus y times x minus y. You could also double check this because you could distribute it so it becomes x squared minus xy plus xy minus y squared, which is just x squared minus y squared. So we are done with these practice questions. Okay, here are some challenge questions. I'll give you guys like 5 minutes to work on these. These ones are kind of hard, so they're going to take some time. Oh wait, I made a mistake on the previous one. So for this one, I forgot the 7, so it's actually 12, not 5. Sorry about that. Someone pointed it out to me. Okay, let's go over them. So for the first one, so basically you want the expression to be the same for all values of x. So when you want it to be the same for all values of x, you think that you want the expression to be constant, meaning it has a numerical value. So for this expression to have a numerical value, you want the x's to cancel out. So when you write this expression out, you get 3x plus 21 minus blank times 2x plus 9. Since you want the x's to cancel out, you want the constant here to multiply to 2x to get 3x. So I claim that the answer is 1.5. I'll show you how. So if this right here is 1.5, then it becomes 3x minus 13.5. So the x's cancel out. So 3x and this cancels out. So this becomes 7.5. No matter the x, this expression will always be 7.5 because x is not affecting this. So our answer for this is 1.5 or 3/2. Okay, so for the second one, this one's kind of hard. So basically what you have to do is like, hey, let me rewrite it. It's basically okay, so basically what you have to do is you have to multiply by the conjugate of this. This is like this is something you'll probably see on like AMC 10, AMC 8 a lot. But basically what you do is you multiply this by root x plus 1 plus root x minus 1. And if you multiply something to the denominator, you have to multiply to the top. So you multiply the same thing to the top. So when you do this, it basically becomes x plus 1. Remember how we did a plus b times, or x plus y times x minus y is x squared minus y squared. So it's just going to become x plus 1 minus x minus 1. And this is simply just 2. So the denominator becomes 2. This just becomes 2. And then the numerator, you're basically squaring this because you're multiplying by the same thing. And that just becomes x plus 1 plus x minus 1 plus 2 times root x plus 1 times root x minus 1. So the numerator will just become 2x minus 2 plus 2 root x squared minus 1. This should be equal to 3 times 2. So this should be equal to 6. Then you add 2 to both sides, and you subtract 2x to both sides, so you get 8x. Wait, let me just erase this. So you're going to get 8x, 8 minus 2x is equal to 2 root x squared minus 1. Now you can divide both sides by 2. So you're going to get 4 minus x is equal to root x squared minus 1. And now the question should become easy. Now you can just square both sides. So, and also a minus b whole squared is a squared plus b squared minus 2ab. So this will just be x squared plus 16 minus 8x. This should be equal to x squared minus 1. So now you add 1 to both sides, and you can cancel these x squareds out. So you're going to get 17 minus 8x is equal to 0. So now you know x is 17 over a. So that's the value of x that works. That was a pretty hard one. So don't be sad if you couldn't solve it. Okay, so for the third one, it's asking what value of a is there such that the equation has no solution for x? So this one you kind of have to think like about the denominator. So if I put x is equal to 3, then the denominator becomes 0. And you're not allowed to have a denominator of 0. So what you want to do is you want to solve it so that the only solution is 3, but that won't work. So it's good. It's going to become 6x minus a is equal to 3x minus 9. Right? So you solve it, and then if you isolate for a, you're going to get 3x plus 9 is equal to a. And you remember how I said the denominator cannot be 3. So if I put x is equal to the x cannot be 3. Sorry, the denominator can't be 0. So if x is equal to 3 is the only solution to this equation, then that a will not set. There's going to be no x for that a such that there's a solution. So when x is equal to 3, we're going to get 3 times 3 plus 9 is equal to a, or 18 is equal to a. So I claim that the answer is when a is equal to 18. We can test it out. So when a is equal to 18, we're going to get 6x minus 18 is equal to 3x minus 9. And the only solution to this equation is when x is equal to 3. And the only solution for this is when x is equal to 3. But when x is equal to 3, then the denominator becomes 0. When x is equal to 3, the denominator becomes 0. So there's no solution for this. So our answer is a is equal to 18. Okay, so for number 4, there's kind of 2 ways to do this, but one way is better to do. I'm just gonna like start the first way, but I'm not gonna finish it because it's kind of bad. So when you consecutive integers basically means the first integer and then the first integer plus 1 plus 2 plus 3. So it's gonna be like x, then x plus 1, then x plus 2, and so on, like that. So if there's 23 consecutive integers, you could write it like x all the way to x plus 22. That's basically 23 consecutive integers. Okay, so you want them to sum to 2, 3, 2, 3. So you basically, if you sum these 23 terms, you're going to get 23x plus 1 plus 2 plus 3 plus 4 all the way to 22. And which is, if you guys know this, it's 22 times 23 by 2. And then that has to sum to 2323. But that way is kind of time consuming. I've seen these type of questions on like AMC 10 where they try to trick you by making you do this, but this is like, oh, this technique wastes a lot of time. The better technique to use is let the middle, since there's 23 numbers, there has to be a middle number. Let the middle number be x. So the middle number in this case would be like the 12th number, because there's going to be 11 numbers ahead of x and 11 numbers behind x. So the number ahead of x would be x plus 1, and this number would be x minus 1. And you can keep on writing the numbers like this, so x plus 2, and then x minus 2. And then this goes all the way down to x minus 11. And this goes all the way up to x plus 11. So now when you sum these numbers, the good thing about this technique is the constants cancel out. So this negative 11 will cancel with this plus 11. The negative 2 here will cancel with this plus 2 right here. The negative 1 will cancel with the plus 1. So when you sum them, it just becomes So when you sum them, it just becomes 23x. That's all it becomes, where x is the middle number. So you get 23x is equal to 2323. And if you do 2323 over 23, you're going to get x is equal to 101. And the numbers go up to x plus 11, and they go all the way down to x minus 11. So you're trying to find the largest of these integers. So the largest integer will be x plus 11 in this list. And x plus 11 will just be 112. So that technique is much faster. I would recommend using that technique. But if you have time, I mean, if you just want to experiment, you could try the first technique, but it's not worth it. Okay. Yeah, so that's it for the class. You can like review the session again at the Alphademic YouTube channel. And you can, if you have any issues, you can also tell me right now if you have any issues. So yeah. Thanks for listening, I guess. Okay, so for number 2, what you have to do is like, let me write this. So you have root x plus 1 plus root x minus 1 over root x plus 1 minus root x minus 1. So what you want to do is when you see these type of equations, you want to multiply by this plus this. Because you remember how we said x squared minus y squared is equal to x plus y into x minus y. So we showed that before. So using that, what we can do is we can let this be like a, let's just say that's a, and let this be b. Then you can multiply by a minus b. You can multiply a minus b times a plus b. You can multiply this by